In the ancient world, the idea of reaching for the sky was a dream that was often crushed by the weight of stone, the limits of human muscle, and the simple problem of gravity. From the mud brick cities of Mesopotamia to the marble temples of Greece, tall structures were rare, difficult, and often dangerous. In this video, we will slowly and quietly explore why ancient civilizations, despite their genius, could only build so high. We will talk about the materials they had, the tools they didn't, the people who carried everything by hand, and the harsh truths of engineering with no machines. Prepare to travel through dusty roads, ancient quarries, sun-drenched deserts, and bustling city-states where the tallest building was often no more than a handful of stories high. This is boring history for sleep. Why tall buildings were nearly impossible in the ancient world. Please watch until the end, and as you listen, let your mind relax into the slow rhythm of the past. Leave a comment to let us know how you're feeling right now. Your thoughts matter, even if they come with a yawn. Now, let's begin with the long first part of our journey through the quiet struggles of ancient architecture, where stone was heavy, labor was slow, and the skies remained out of reach. In the earliest human settlements, structures were built with what was available directly underfoot: mud, clay, straw, and occasionally wood formed the backbone of the first shelters. In Mesopotamia, among the marshes and floodplains of the Tigris and Euphrates, early humans learned to shape mud into bricks, drying them in the sun, then stacking them to make homes, temples, and walls. But mud brick, as useful as it was, had its weaknesses. It absorbed moisture, cracked with temperature changes, and crumbled over time. Worse, it was heavy. One dried mud brick could weigh several kilograms, and building even a modest wall took hundreds, if not thousands. To build a structure 2 or 3 stories tall was already a feat of logistics and manpower. The ziggurats of ancient Sumer seem like exceptions, rising high with steps and platforms. But even these were not truly buildings in the sense of habitable floors stacked vertically. Rather, they were terraced platforms, wide, solid, and tapered to distribute weight downward. Inside, they were often filled with packed earth or rubble. There were no elevators, no steel frames, and no windows peering down from great heights. Climbing them was more a ritual than a daily activity, and only the priests or elite would ascend. The ordinary people stayed grounded, literally and figuratively. In ancient Egypt, stone took over from mud. The pyramids, massive and majestic, remain some of the tallest man-made structures from the ancient world. Yet they too were not vertical buildings in the way we think of modern towers. Each layer was carefully cut and placed, the angle of the pyramid spreading the weight out and down. The Great Pyramid of Giza, for example, stood as a marvel of engineering, but its internal space was quite small. Most of it was solid stone, a building with many high levels, inhabited by people, supported only by stone, and without reinforcing. Steel was simply not practical. The process of quarrying the limestone and granite, transporting it with sledges or boats, and then lifting it into place with wooden ramps took decades. It's likely that tens of thousands of laborers worked over many years, using simple tools and raw human effort. Even lifting a single stone block weighing 2 tons was a monumental task. Ramps had to be built, extended, maintained, and later dismantled. Each stone had to be set precisely. This made tall structures not only expensive but painfully slow to construct. And because the structure was entirely dependent on the lower layers supporting the weight above, any mistake near the base could bring down the entire project. Greeks and Romans advanced building technology further, yet their tall buildings remained modest by modern standards. In Athens, marble temples rose over the city, with the Parthenon crowning the Acropolis. But again, These were wide structures, with open interiors and solid, low ceilings. Marble was heavy. Columns were thick because they had to be. Beams and roofs had limits. Wood, the material often used for roofing, had its own problems: rot, fire, and warping. A taller building required longer beams, but the longer the beam, the more likely it would bend or break under its own weight. So, buildings stayed low to protect lives, preserve stability, and respect the limits of material strength. Even in Rome, where engineering flourished and innovations like concrete allowed for arches, domes, and aqueducts, vertical growth remained constrained. Roman apartment blocks, known as insulae, reached up to 5 or 6 stories in the most daring cases, but they were notorious for collapsing or catching fire. The higher the floor, the more dangerous the dwelling. Upper floors were often reserved for the poor, who had to climb unstable wooden staircases and live under leaking roofs. It was not uncommon for these buildings to fall. Emperor Augustus passed laws to limit building heights. Even in a city that built the Colosseum and the Pantheon, going too high was asking for trouble. What held ancient buildings back was not a lack of ambition, but a combination of materials, tools, and physics. There was no reinforced concrete, no steel beams, no elevators. The human body could only carry so much, and the winches and pulleys of the time had limited strength. It took hundreds of people to lift what a modern crane could manage in minutes. Scaffolding was made from wood and rope, prone to collapse in storms or under strain. Safety was minimal. Accidents were common. Risk was constant. And every meter upward brought new problems. Wind pressure increased. Weight accumulated. Foundations had to be deeper and wider. Laborers had to climb higher, rest more often, and carry tools and materials up narrow paths. The higher the structure, the slower the work. Most civilizations chose stability over height. A strong single-story house was better than a risky 4-story tower. Urban planning focused outward expansion, not upward stacking. Public spaces, courtyards, markets, and baths were more important than high buildings. Even temples and palaces prioritized grandeur on a horizontal scale, sprawling complexes with columns and colonnades, rather than tall, cramped towers. Architecture was symbolic, aesthetic, functional but rarely vertical. The ancient Chinese built pagodas. The Indians raised tall temple spires, and the Mayans constructed stepped pyramids in the jungle. But again, these structures served ceremonial or symbolic roles. Living in them was rare. Climbing them was a religious act, not part of daily life. Their height was not practical, it was impressive. They were messages to the gods, not comfortable homes or practical office spaces. And so, height remained a sacred, unreachable thing. Even the challenge of transporting materials discouraged. Building tall, without tracks or railways, everything had to be moved by cart, beast, or boat. Stones cracked, beams snapped, roads flooded, rain turned paths into mud. A project could be delayed by years simply because the right stone couldn't be delivered. Thus, in the ancient world, tall buildings were nearly impossible, not because people lacked imagination, but because the world itself pushed back. Gravity, material limits, labor shortages, and technological boundaries all conspired to keep people close to the ground. In time, innovation would overcome some of these limits, but for millennia, the sky remained a quiet ceiling above a flat world. And that is the beginning of our long, slow journey into understanding why height was a rare and fragile achievement in the ancient world. In the next part, we will explore the tools used by ancient builders, what they had, what they lacked, and how they made up for centuries without machines. The tools of the ancient builder were simple, slow, and shaped entirely by the materials of their time. There were no power drills, no laser levels, no heavy-duty cranes. The hammer was often made of stone or bronze. The chisel was forged by fire but dulled easily with use, and the saw required not only strength but patience. The most advanced tools might include a pulley or a basic lever, both brilliant inventions for the time, but limited in their lifting power. The labor of building in the ancient world was not a matter of machines, but of men. And those men used their hands, their backs, and the simplest of devices to move the heaviest of stones. A typical building site in ancient Mesopotamia or Egypt was loud with the rhythm of effort, the thump of sledges against the earth, the scrape of stone against stone, and the shouting of overseers guiding teams of workers. Ramps were constructed beside the buildings, not as part of the final structure, but as temporary platforms that allowed materials to be dragged upward. These ramps were sometimes made of compacted earth, or of bricks that would later be dismantled once the building reached its final height. But constructing the ramps themselves required labor and time. Every step upward increased the slope or length of the ramp, meaning more distance to carry every stone. The lever, perhaps the simplest machine, was a trusted companion to the ancient builder. A log placed under a heavy object with a rock as a pivot could lift weights that a man could not move alone. But even levers had limits. If the object was too large or the lever too weak, the effort would fail, and the risk of injury was constant. Workers in the ancient world had no safety gear, no steel-toed boots, no gloves, and no modern medical help. A slipped stone could crush a foot or a hand. A snapped beam could shatter ribs. Accidents on the construction site were common, and death was accepted as part of the work. Pulleys helped, but only to a certain point. A single pulley might change the direction of a force, allowing a rope to lift instead of drag. But it did not reduce the weight of the load. Compound pulleys, which used multiple wheels to reduce the force needed, were known in later periods, especially by the Greeks and Romans. But even these could only lift so much before the rope snapped or the wood cracked. And ropes were made from natural fibers, twisted reeds, animal sinew, or rough plant material, none as strong as modern synthetic cords. Over time, they frayed, stretched, and broke, especially under the strain of repeated lifting. The level and the plumb line were essential for precision. Builders needed straight lines and flat surfaces, especially when stacking stone. A level might be as simple as a shaped frame with a string and a weight dangling at the center. It was not exact by modern standards, but it was surprisingly effective. When used carefully, the plumb line, the hanging string with a weight at the end, helped ensure vertical alignment. Still, without precise measuring devices, small errors accumulated. A wall that was slightly off at the base could lean precariously after only a few meters. Builders had to constantly adjust, check, and redo their work to maintain balance and avoid collapse. Then there was the matter of cutting and shaping stone. In Egypt, for example, huge blocks of limestone and granite were quarried with copper tools. Copper is soft by today's standards, and chisels had to be reshaped or replaced constantly. Workers used dolerite balls, harder stones to pound shapes into softer rock. This took hours, sometimes days, just to prepare a single block. Dust filled the air. Sweat soaked the workers. Every edge was carved by hand, every corner checked by eye. The margin of error was slim, especially when thousands of blocks had to fit together in a structure meant to last centuries. In Greece, marble was prized for its strength and beauty, but also for its stubbornness. Cutting marble required a saw, often used with abrasive sand and water, pulled back and forth until the stone wore down. This process was slow and tiring. Builders needed skilled laborers, not just brute strength. A single column for a temple might take weeks to prepare, and still needed to be transported, aligned, and raised into position. Mistakes were costly. If the column cracked, the entire piece might be discarded. Raising columns was a challenge on its own. Ancient builders used earthen ramps, wooden scaffolds, or inclined platforms. The column, laid horizontally, would be pulled upward slowly using ropes and wooden cranes. Simple devices with a turning drum, hand-cranked by teams of men or animals. Once raised, the column had to be guided into a vertical position and lowered onto its base with precision. A misaligned capital could cause a column to lean or even topple. And with no way to glue or weld the pieces, alignment depended entirely on balance and craftsmanship. Some cultures made clever use of counterweights. In ancient Rome, for example, engineers designed hoists that used heavy stones or barrels of water as balancing weights, helping to lift materials by shifting gravity. These systems were brilliant but still limited by material strength. A single rope or beam could only hold so much before giving way. And if one part failed, the entire system could collapse, sending workers and stones crashing to the ground. Wind and weather also played their part. A strong breeze could destabilize a crane or shift a heavy stone as it was being lifted. Rain turned ramps into mudslides. Lightning storms posed a danger to tall scaffolds. Builders had to time their efforts carefully, working in seasons with dry weather and long daylight. Winter halted progress in many places. Even in warm climates, the scorching heat of midday forced workers to rest or risk collapse from exhaustion. Every hour of construction was dictated not only by tools and manpower but by nature itself. Because of all these factors, construction timelines stretched into years, sometimes decades. The Parthenon in Athens took nearly 15 years to build. Even with a relatively modest height, the Great Pyramid likely took over 20 years, with tens of thousands of workers laboring every day. In some cases, construction was never finished. Monuments and temples were left half-built when wars broke out, rulers died, or resources ran dry. Columns stood incomplete, walls ended in rubble, and stone blocks were left abandoned where the work had stopped. In a world without machines, every lift was a trial, every measurement a guess, and every day brought the risk of delay. And this is why, even when the ambition to build tall existed, the ability did not always follow. It was not just the dream that mattered, it was the slow, grinding reality of ancient construction. One stone at a time, 1 inch at a time. In the next part, we will explore how ancient societies organized labor to take on these monumental tasks. Who built the temples, towers, and walls? Were they slaves, citizens, conscripts, or craftsmen? How did entire cities come together to build structures that would stand for centuries? These questions will guide our quiet and careful journey deeper into the world of ancient architecture. To build anything in the ancient world, and especially to build something large, required more than stone and tools. It required people. Not just a few, but hundreds, sometimes thousands, working together in long shifts, day after day, under sun and wind and time's patient wait. Organizing labor in the ancient world was as important as the architecture itself. Without the laborers, no structure could rise, no temple could shine, and no city could hope to expand beyond a few short walls. And so, societies across time developed systems to direct, support, and sometimes force human effort toward their lofty dreams. In Mesopotamia, some of the earliest large-scale constructions were the result of state direction. The city-states of Sumer and Akkad organized work through temple economies, where the ziggurat or temple was the religious and administrative center. Farmers might be required to work on public projects during seasons when fields were fallow, especially in the dry season when irrigation canals were also maintained. Labor could be offered as a tax, days of toil instead of coin. Entire communities could be summoned to haul bricks, mix clay, or shape timber, all for the glory of the gods and the stability of the city. Yet even then, most people lived short. Hard lives and worked from necessity rather than enthusiasm. The laborer was not often thanked, nor remembered by name. In Egypt, the scale of labor reached an unmatched magnitude during the age of the pyramids. For centuries, it was assumed that slaves built the pyramids, sweating under whips and cruel overseers. But modern archaeology has revealed a more nuanced truth. While forced labor existed in many periods, the workers who built the pyramids were often well-fed specialists, skilled masons, carpenters, and laborers organized into rotating crews. They lived in nearby villages, ate bread and meat, drank beer, and worked in shifts for months at a time. Their bones show signs of wear and injury, but also of medical care and healing. These were not prisoners. They were people with families, with roles, with lives. Still, the task before them was monumental. Every block hauled, every ramp built, was the result of thousands of coordinated movements. The organization of labor in Egypt required logistical genius. Water had to be brought in, food prepared daily, shelter constructed, and tools maintained. Scribes tracked progress. Foremen gave orders. Artisans carved out stone blocks from quarries, and others dragged them with ropes and sledges to the river, loaded them onto boats, and floated them downstream. On arrival, yet more workers would haul them inland to the pyramid site. Even a delay in one stage could halt progress entirely. The workers' days were long, filled with repetitive motion, and their nights likely short and sore. In ancient Greece, labor was more fragmented. Cities like Athens relied heavily on skilled craftsmen and the enslaved population. Slavery was common and widely accepted, with many public works being built in part by enslaved hands. But large projects also drew on the free population. Skilled artisans, members of trade guilds, or foreign specialists might be hired for their expertise in stone carving, bronze casting, or woodwork. The construction of the Parthenon, for example, was a civic project funded by the city-state and intended to showcase its glory. Wages were sometimes paid, although modest. Projects of prestige, like temples or stoas, often involved pride as much as pay. Citizens might volunteer or be selected by lot to serve in supervisory roles. Yet always, below the planners and architects, it was the hands of the nameless many that moved the stones. Rome brought labor organization to a new level. The empire's expansion enabled it to draw resources and manpower from across a vast territory. Soldiers built roads and forts as part of their service. Enslaved workers, captured from war or born into bondage, were used in private and public construction alike. But Rome also had a thriving class of engineers and construction experts. Wealthy citizens could fund projects through patronage, offering a new bathhouse, aqueduct, or public hall in return for glory and honor. These donations funded materials, tools, and the hiring of labor. The state also maintained a vast bureaucracy to oversee such works. In the city of Rome itself, laborers worked in rotating teams to maintain the aging buildings, repair infrastructure, and respond to fires or collapses. The laborers of ancient Rome lived in crowded districts, often in rented rooms within tall, unstable insulae. Their workdays began at dawn and ended when light faded. They might carry bricks up ladders, mix mortar by hand, or chip stone under the direction of a master builder. The pay was small, injuries were frequent. Their names, too, have mostly been lost. But in rare cases, inscriptions mention teams of builders, craftsmen, and masons, proud enough of their work to leave it etched in stone. In India and China, the labor systems were similar in spirit, if not in detail. Large religious structures, such as Hindu temples or Buddhist stupas, required the coordination of thousands. In India, temple towns became centers of craft and culture, with sculptors and stoneworkers devoting years to a single structure. In China, imperial projects like the Great Wall or palaces in Chang'an required massive conscription. Laborers were drawn from the peasantry, and those who resisted might be punished. Families were separated. Conditions were harsh, and yet the scale of ambition was unmatched. Labor organization was not just a question of physical bodies. It required food storage, transport, planning, weather monitoring, leadership, and above all, time. And as buildings grew in height, all of these demands increased. A single extra story meant more steps to climb, more material to haul, and more stress on every level below. It meant more scaffolding, longer ladders, and greater risk. For the people tasked with doing the work, it meant more fatigue, more danger, and more chances for failure. And so, the decision to build higher was never taken lightly. It wasn't just an architectural challenge, it was a human one. For every additional meter of stone, hundreds of hours of labor were needed. One mistake could mean starting again. One crack in a foundation could doom the structure. Leaders, priests, and kings needed not just vision, but workers willing or compelled to carry it out. In the next part, we will look more closely at the limitations of materials themselves. We will examine the strength of stone, the flexibility of wood, and the absence of the materials we now take for granted, such as steel and reinforced concrete. How did these limitations shape the skyline of the ancient world? And how did builders work around them? In the quiet world of ancient building, materials spoke louder than plans. What one could build depended entirely on what one could find, carry, shape, and place. And for all their ambition, the architects and laborers of the ancient world were bound by the physical realities of stone, clay, wood, and earth. These were the basic ingredients of construction, and they came with limits that no amount of human willpower could easily overcome. For every added height came added weight, and for every weight there needed to be support. Tall buildings demanded not just design, but strong and stable materials, something that ancient civilizations rarely had in abundance. Stone, for all its permanence, was both a gift and a burden. It came in many forms: limestone, granite, basalt, sandstone, marble. Each type had its own strength and weakness. Limestone was soft and easy to carve, but weathered quickly. Granite was hard and long-lasting, but extremely heavy and difficult to cut. Marble offered beauty and polish, but not all marble was created equal. And regardless of the type, stone was heavy. A single block could weigh several tons, and stacking stone meant placing enormous stress on the structure below. Ancient builders had no concept of tensile strength in the way we understand it today, but they observed its effects clearly. Stone was excellent at bearing weight downward, what we now call compression. That's why ancient buildings had thick columns, wide bases, and pyramid-like shapes. These designs spread the weight outward and downward, allowing gravity to do its work safely. But stone was poor in tension. It could not be stretched, pulled, or bent without cracking. And so, ancient builders avoided long horizontal beams made of stone, unless they were short and thick. Roofs and ceilings had to be planned carefully, often relying on wooden beams instead. Wood, lighter and more flexible than stone, was used for roofs, floors, and scaffolding. But wood also came with its own challenges. Not all trees grew tall and straight. In dry regions like Egypt or Mesopotamia, large timber was scarce, and long beams had to be imported or replaced with bundled reeds or palm trunks. Even in forested regions, high-quality timber was valuable and perishable. Wood rotted in damp climates, burned easily, and could warp over time. The absence of strong, durable timber limited how far buildings could span or rise. Clay was abundant and adaptable. In the form of sun-dried mud bricks, it was used across the ancient Near East for homes, walls, and even temples. But mud brick was fragile and vulnerable to weather. Rain could erode it. Fire could destroy it. Only with regular maintenance could such buildings last. In Babylon, great ziggurats were built of mud brick, but they were faced with baked bricks, or bitumen to protect them. Still, these materials could not support enormous vertical loads, and their use placed limits on height. Buildings made with mud brick were wide, not tall, and often rebuilt every few generations. Later civilizations developed concrete-like mixtures. The Romans, most famously, created a material called opus caementitium Roman concrete. It allowed them to build arches, domes, and aqueducts with new strength and freedom. But even Roman concrete, impressive as it was, lacked reinforcement. It was strong in compression, but brittle under stress. The secret ingredient pozzolana, a volcanic ash, gave it durability and resistance to water, but not the flexibility of modern reinforced concrete. Without internal metal supports, even the best Roman structures had limitations on height and span. Another challenge was joining materials together. Today, buildings are held together with bolts, welding, rebar, and industrial adhesives. In the ancient world, joinery relied on gravity, friction, and sometimes pegs, clamps, or lead poured into holes. Stone blocks were often stacked dry, without mortar, relying on their weight to stay in place. Sometimes a thin layer of mortar helped seal gaps, but this material was usually lime-based and not especially strong. In some temples, metal clamps held blocks together, but such methods were limited and time-consuming. In wooden buildings, joints were made with mortise and tenon techniques, dowels, or wooden pins. These required careful craftsmanship, but could not compare to the strength of nails or screws. In places like Japan and China, carpenters developed incredibly complex joints that locked together with precision. But even these systems had height limits. Wood could not carry the load of more than a few stories before bending or collapsing. When buildings grew tall, pressure built not only on the walls but on the foundations. Soil shifted. Weight pressed down unevenly. In cities near rivers, like those in Mesopotamia or along the Nile, the ground was soft and damp. Without deep foundations, something very difficult to construct without modern drilling tools, heavy buildings risked settling unevenly, leading to tilting walls or cracks that widened over time. The taller the building, the more dangerous. The settlement became to resist outward thrust. Some buildings used buttresses, thick external supports that pushed back against the weight of walls and ceilings. But these required space, and in crowded cities, that space was often unavailable. Roofs, too, were limited in their design. Vaults and domes helped spread weight, but only the most advanced civilizations, like the Romans or Byzantines, mastered these techniques at scale. For most of the ancient world, the safest roof was flat or slightly sloped, made of timber, reeds, or tiles. Because of these limitations, even the grandest ancient cities remained mostly horizontal. Temples, palaces, and pyramids might soar in isolated splendor, but homes and shops were usually 1 or 2 stories tall. Apartments existed in some places like the Roman insulae, but they were often dangerous, overcrowded, and prone to collapse. Builders pushed the limits, but only so far. It's important to remember that the ancient world lacked a key innovation: reinforced materials. Steel, which can bend without breaking, and reinforced concrete, which combines tension and compression. Strength did not exist. Without these, tall structures were risky, and wide spans were rare. Builders worked with what they had carefully, slowly, and always aware that the taller they built, the greater the risk. In the next part, we will explore how cultural and religious ideas shaped ancient architecture. Why did some civilizations strive for height at all? What meanings were attached to towers, temples, and ziggurats? And how did belief shape the buildings that still inspire awe today? While materials and manpower shape the practical limits of construction, belief and culture often shape the desire to build. Across the ancient world, civilizations did not build tall for comfort or convenience. They did not seek height for luxury or fashion. They sought it for meaning. Height was a symbol. It pointed upward, toward the heavens, toward the divine, toward the unreachable. To raise a building above the level of common life was to reach for the gods, or, at the very least, to declare power, to impress others, to command space and attention. Religious structures were among the tallest and most prominent buildings. In ancient cities, in Mesopotamia, this was most visible in the form of the ziggurat. These stepped, pyramid-like towers rose in tiers above the flat plains, built from mud brick and faced with fired brick for protection. The ziggurat was not a place where ordinary people entered. It was not a temple in the modern sense, but a raised platform, a stairway for the gods. On its summit stood a small shrine, thought to house the deity's presence. The higher the platform, the closer it came to the sky, the realm of divine forces. The Etemenanki in Babylon, dedicated to the god Marduk, was one of the most ambitious. Some believe it inspired the later biblical story of the Tower of Babel. Its base measured nearly 100 meters on each side, and its height may have reached a similar measure, though erosion, time, and rebuilding make exact dimensions uncertain. Still, even at its height, it was built with mud bricks and faced many limitations. It needed regular repairs, careful drainage, and endless labor. Its height was not practical. It was symbolic. In ancient Egypt, the pyramid was the most famous example of height used as a statement of belief and authority. The Great Pyramid of Khufu, built around 2560 BCE, stood over 140 meters high, an astonishing height that would not be surpassed for thousands of years. It was not a palace, not a temple, not a place to gather. It was a tomb. It was designed to connect the pharaoh with the gods, with the stars, and with eternity. Its shape, broad at the base and narrowing to a point, reflected the rays of the sun and pointed upward toward the sky. The Egyptians believed in an afterlife above the earth, and the pyramid served as a ramp to that higher world. Inside, passageways and chambers were carefully aligned with celestial events. But though it reached upward, it was not a building. For living, it was a monument of stone and silence. In ancient India, height was also a sacred direction. The stupa, a mound-like structure, evolved over time into more complex forms. At first, these were simple domes covering relics of the Buddha. But over centuries, towers called shikaras and vimanas rose above temple complexes, each one representing a mountain, the cosmic mountain Meru at the center of the universe. In Hindu temple architecture, verticality was not for people but for gods. The higher the tower, the more sacred the space beneath it was considered. Pilgrims might circle the temple, admire the tower, and offer prayers, but few would ascend it. Height here was spiritual, not functional. In China, tall buildings were rare until the introduction of pagodas, tiered towers built initially to house Buddhist relics. Influenced by Indian stupas, they developed into elegant, multi-storied wooden structures with sweeping roofs and symbolic symmetry. But Chinese architecture traditionally favored horizontal balance. Palaces, homes, and even temples were arranged in courtyards and wide halls. Towers existed, but they were rare, and their construction was difficult due to the limitations of timber and joinery. Earthquakes and fire posed constant threats to tall wooden buildings, and so verticality remained symbolic. Used sparingly and carefully in the Greco-Roman world, public buildings rose for glory, not worship. Temples, like the Parthenon, stood atop hills or platforms, their columns creating a sense of height and openness. But few Greek structures were truly tall. Their architecture emphasized proportion, symmetry, and visual harmony, not vertical dominance. The Greeks built for beauty, for civic pride, and for ritual, but rarely for skyward stretch. The Romans, more ambitious in engineering, experimented with height in ways others did not. The Colosseum, the great amphitheater of Rome, rose over 4 levels high and could seat tens of thousands. Multi-storied insulae, or apartment blocks, reached up to 6 or 7 stories in some cities, though with great risk. Roman bathhouses, basilicas, and temples featured high vaults and domes. The Pantheon, with its massive dome and oculus, was a wonder of engineering, its open eye to the heavens, drawing in light and symbolizing the connection between the divine and the earthly. Yet even the Romans, with their concrete and arches, faced collapse, fire, and decay in tall structures. What emerges across all these cultures is a common theme. Height was reserved for the sacred, the powerful, or the symbolic. Ordinary people lived close to the ground. Homes were small, dark, and low. Roofs leaked, walls cracked, and few rooms had space to stand tall. Only kings, gods, or empires could claim the sky. And even then, their grasp was limited. No structure reached truly high without tremendous cost. No building stood forever. In the next part, we will examine the tools of the ancient builder, the simple instruments and clever techniques that allowed people to shape stone, raise columns, and align structures with the stars. Without modern machinery, how did ancient architects create buildings that still stand today? The creation of even a modest structure in the ancient world required more than muscle. It demanded tools simple, often handmade, but essential, and a knowledge of geometry, astronomy, and craftsmanship passed down through generations. Tools, unlike modern machinery, did not hum with engines or shine with polished metal. They were quiet, rough, slow to use, and easily broken. But they were just enough to shape stone, measure angles, lift heavy materials, and align structures with the sun and stars. One of the most vital tools was the plumb bob, a pointed weight suspended from a string. It helped ancient builders establish vertical lines. A straight up and down measurement was crucial for walls, columns, and doorways. Without it, buildings would lean, tilt, or collapse over time. The simplicity of the plumb bob hid its genius. It worked purely by gravity, and it told the truth no matter the setting. Whether used in Egypt, Mesopotamia, Greece, or China, it offered a shared answer to the question: is this truly vertical? To measure horizontal levels, builders turned to water levels, long tubes partially filled with water, or to wooden devices, called A-frames with hanging plumb lines at their center. These simple tools allowed architects to create flat floors and balanced platforms. Without spirit levels or lasers, they relied on the steady pull of gravity and the surface of still water. Angles were calculated using simple set squares and knotted ropes. A rope tied into 12 equal segments could be stretched into a triangle with sides measuring 3, 4, and 5 units of Pythagorean triangle. This allowed builders to lay out right angles on the ground, essential for creating rectangular buildings, straight walls, and symmetrical courtyards. In ancient Egypt, Surveyors called harpedonaptor were experts in this kind of rope geometry. They were responsible for aligning pyramids and temples with astonishing precision. Cutting tools were limited by the materials available. In the early periods, bronze chisels and copper saws were common, though they wore down quickly against stone. Later, iron and steel tools allowed deeper carving and greater durability. Hammers, picks, and mallets chipped away at blocks, slowly shaping them for placement. Sawing stone required patience, sand, and repetitive motion. For the harder stones, like granite, workers used dolerite hammers, heavy, rounded stones swung by hand to pound and shape to lift heavy blocks. Ancient builders invented clever devices. Levers, rollers, and sleds were common, powered by teams of humans or animals. Stones could be dragged across greased paths or floated on barges through canals. In some cases, ramps were built along gradual slopes of earth or brick that allowed materials to be pulled upward. The exact method used to build the Great Pyramid remains debated, but most scholars agree that some form of massive ramp system was necessary. Lifting even a single block to height required teamwork, coordination, and time days or even weeks for a single placement. Later civilizations improved on lifting techniques. The Greeks and Romans used pulleys, cranes, and winches. Wooden cranes powered by treadmills, giant wheels walked inside by men or animals, could lift several tons. These machines were fragile, made entirely of timber and rope, but they allowed greater precision and saved countless hours of labor. Roman construction sites often featured cranes on rotating platforms, allowing materials to be swung into place from various directions. Scaffolding was built of wood or bamboo, tied together with ropes or vines. It had to support not only the weight of workers but also the materials they carried. In some places, scaffolds were permanent parts of the building process. In others, like China, where timber was abundant and construction emphasized timber frames, scaffolding became a refined craft in itself, flexible, strong, and reusable. Measuring distances across long stretches of land required more than just pacing. Surveyors used groma in Rome, a cross-shaped device with weighted strings, to establish straight lines and right angles across fields or city plots. Others used dioptra, an early version of the theodolite, for measuring angles. These instruments were mounted on tripods and turned slowly to align features over distances. But beyond tools and measurements, ancient builders relied on the sky. Many temples and monuments were aligned with celestial events. The rising sun on solstices, the setting of specific stars, or the north-south axis. The ancient Egyptians aligned pyramids with the cardinal points using stellar observations, possibly by watching the rotation of stars around the celestial pole. In Mesoamerica, structures like those at Chichen Itza were positioned to create dramatic shadows during equinoxes. These alignments required careful watching over years, sometimes generations, to mark and confirm. Builders became astronomers, and astronomers became part of the construction process. In all this, time was the most abundant tool. Ancient buildings were not rushed. Projects lasted decades, sometimes centuries. A single pharaoh might commission a tomb that his grandson would finish. A Roman aqueduct could take 50 years to complete. Temples in India were built layer by layer over dynasties, each king adding a section, each generation preserving the work of the last. Mistakes were common. Stones cracked, foundations shifted, tools broke. Builders compensated, adapted, and repaired. There were no blueprints in the modern sense, no digital models or simulations. Each building rose from a combination of skill, vision, and trial and error. And when a structure failed, as many did, it served as a lesson for the next attempt. In the next part, we will explore the human cost of building in the ancient world. What was it like to work on these towering projects? Who were the laborers? What did they endure? And what risks did they face as they tried to raise the earth toward the sky? Behind every ancient structure, whether a humble home, a lofty ziggurat, or a towering pyramid, stood the hands and backs of countless laborers. Their names are mostly lost to time. Their stories, seldom recorded, live on in worn tools, uneven steps, and the rough fingerprints left in dried mortar. Without them, no building would have risen. Yet they are often absent from the history books. And while the structures may seem eternal, their construction was built on effort, endurance, and often exhaustion. The nature of labor varied across regions and periods. In some places, it was seasonal. In Egypt, for example, during the annual flooding of the Nile, when farming halted, peasants were drafted into construction crews. These men, working in large groups under overseers, hauled stone, prepared mud bricks, dug canals, and cleared paths. They received food, beer, shelter, and possibly medical care. Though not slaves in the strictest sense, their work was mandatory. A civic duty owed to the pharaoh, who was not merely a king, but a divine figure. In return, workers believed they were helping build eternal monuments, sacred spaces where gods and ancestors would reside. At places like Deir el-Medina, where craftsmen lived while building tombs in the Valley of the Kings, more is known. These artisans and laborers lived in a walled village, received regular rations, and worked in organized teams. They painted walls, carved stone, and recorded their days on ostraka fragments of pottery that served as notepads. These records show disputes, strikes over food delays, and even moments of laughter and poetry. The work was hard, but the workers were skilled and respected. Still, their lives were ruled by schedules, quotas, and the ever-looming weight of royal expectation. Elsewhere, labor was harsher. In Mesopotamia, forced labor was common. Prisoners of war, debtors, and slaves were pressed into service. Building the great ziggurats required thousands of hands, some willing, many not. Under the burning sun of the plains, they mixed mud, fired bricks, and carried loads up steep ramps. Injuries were frequent, accidents likely, but records remain silent on their suffering. In ancient Greece and Rome, public construction was sometimes paid for by wealthy benefactors, but the labor came from a mix of slaves, freedmen, and hired workers. Slaves, especially those skilled in masonry or carpentry, were considered valuable property. They built temples, aqueducts, amphitheaters, and homes, often under supervision. In Rome, large building projects were organized with military precision. Engineers issued commands. Laborers obeyed. Cranes lifted stones. Roads were built. But collapse, fire, and cave-ins were constant threats. Roman insulae, the multi-story apartment buildings of the poor, were especially dangerous. Built quickly, often of wood and cheap concrete, they were prone to toppling. Fires spread easily. Staircases gave way, and overcrowding made escape difficult. Maintenance was minimal. Those who lived or worked in them accepted the risks. As the city swelled and space became scarce, the laborers who built them were under constant pressure to complete work fast and cheaply. In China, construction workers carved earth into mighty rammed earth walls. This method involved pounding layers of soil, gravel, and lime into forms to create solid walls. It was used in city walls, fortresses, and even parts of the Great Wall in its earlier stages. Workers faced extreme weather, difficult terrain, and strict discipline. Some accounts describe entire crews being buried in collapsed sections, their bodies unrecovered. Though the Great Wall as it appears today was mostly built during the Ming Dynasty, Earlier sections stretched across centuries of sacrifice. In the Americas, the builders of structures like the pyramids of Teotihuacan or Machu Picchu worked without the wheel or draft animals. Stones were carried on the backs of people, dragged with ropes or lifted with lever systems. In Incan lands, the stonework was so precise that blades could not pass between the blocks. Yet this precision required endless labor. Workers prepared stones at distant quarries, shaped them to fit exactly with their neighbors, and rolled or slid them across mountain paths to the construction site. The working conditions were shaped not only by climate and tools, but by belief. In many cultures, building sacred structures was not just a job, it was an offering. Workers left votive objects beneath temple floors, placed amulets inside walls, or marked stones with symbols for luck and protection. In some cases, legends suggest that human sacrifices were made to bless the foundations of great structures, especially bridges or walls meant to endure. Whether literal or symbolic, these stories show the deep link between building and the sacred. Despite the dangers and hardships, workers developed remarkable skill. Stonemasons learned to read the grain of stone. Brickmakers knew when the clay was right. Carpenters adjusted joinery based on the wood's moisture. Knowledge passed through families and guilds, rarely written, always taught by hand. A master builder might oversee dozens of projects in a lifetime, shaping cities and temples, yet remain nameless to history. The structures they built, however, endured, at least in part. Foundations sunk, walls cracked, towers collapsed. But some stones remained, resting just where they were laid centuries ago. And though we often admire the grandeur of ancient architecture, it is in these quiet remnants that the labor of the forgotten becomes most visible. In the next part, we will look at what happened after construction, how ancient buildings aged, how they were maintained or abandoned, and how weather, time, and disaster wore them down, making tall buildings even more impractical in the long term. Once the last stone was laid, once the final brush of plaster or touch of gold leaf had been added, a building entered a new phase of life. Not construction, but endurance. And in the ancient world, endurance was a battle against time, nature, and circumstance. No matter how carefully a structure had been planned, or how skillfully it had been built, the forces of decay waited patiently. A building that reached toward the sky had more to lose. Height made it not only more impressive, but also more vulnerable. The most immediate threat to tall buildings was weather. Rain soaked the bricks of ziggurats in Mesopotamia, causing erosion and collapse if not regularly repaired. Sun baked clay until it cracked. Wind tore at rooftops, especially those raised high above surrounding homes. In cold climates, freezing and thawing widened cracks in stone. In hot regions, heat caused materials to expand, sometimes unevenly, stressing joints and seams. The sky, so often the inspiration for building upward, became the very thing that punished the effort. Earthquakes were another challenge, especially in regions like the Eastern Mediterranean, Persia, and parts of Asia. A tall building built on a rigid foundation with heavy materials was particularly susceptible to collapse. The shaking of the earth could unsettle walls, shift cornerstones, and bring entire towers down in seconds. Without reinforced materials or flexible design, few tall ancient structures could survive even moderate seismic activity. Then there was fire, perhaps the most destructive and feared threat of all. In cities where buildings stood close together, like Rome, Athens, or ancient Chang'an, a single spark could consume entire neighborhoods. Tall buildings made of wood were tinderboxes. Flames leapt from floor to floor, carried by wind. Once ignited, The upper stories were often unreachable to those fighting the blaze with nothing more than buckets and blankets. Fire not only destroyed the building itself but weakened nearby walls, melted roofs, and sent beams crashing down. After such a fire, rebuilding often meant starting from scratch. In many regions, buildings suffered from flooding. The Nile, the Tigris, the Euphrates, all rivers that gave life, also carried away mud brick foundations and wooden supports when waters rose. Low-lying cities had to rebuild constantly. Tall buildings fared worse. When a foundation shifted or washed away, the higher the structure, the greater the risk of complete failure. Once a wall leaned or cracked, it often could not be saved. Beyond nature, buildings faced neglect. After a ruler died or a dynasty fell, temples, palaces, and towers often lost their caretakers. Without regular repairs replacing worn bricks, resealing joints, cleaning gutters, the structure deteriorated. In the ancient world, there were no modern maintenance teams. Upkeep was a responsibility passed from hand to hand. Once interest or resources waned, even the grandest building began to fade. Roofs leaked, weeds grew in cracks, birds nested in forgotten rafters. Slowly, the earth reclaimed its share. War and conquest brought deliberate destruction. Invading armies toppled statues, tore down towers, and burned temples. Buildings that symbolized power were prime targets. A tall structure served not only as a landmark, but as a symbol of dominance, and enemies knew it. Siege warfare often included attempts to undermine or scale high walls and towers. Stone could be shaken loose, set on fire, or battered with rams. A building that had taken decades to build could be destroyed in days. Materials played a role as well. In ancient times, recycling was common not for sustainability, but out of necessity. When an old building fell out of use, its stones were often taken to build new structures. Bricks were pulled from walls, columns dismantled, and statues reused. Many temples and fortresses were not destroyed by time alone, but by people stripping them down for parts. Tall buildings, with their large stone blocks and carved features, were often attractive sources of material. Even animals and plants posed subtle threats. Roots from trees grew into foundations, slowly breaking them apart. Moss and lichen crept along walls, retaining moisture and weakening joints. Birds made nests in eaves and rafters, dropping debris that could clog drainage. Rodents burrowed into wooden supports or storage rooms, weakening the very timbers that held upper floors in place. Despite all this, some buildings did survive. They did so through a mix of location, fortune, constant care, and, often, sheer mass. The pyramids of Egypt survived not because they were especially practical, but because their form was stable, broad at the base, gradually narrowing with little to collapse. They required little maintenance because they served no ongoing function. They simply stood. The Parthenon in Athens survived earthquakes, wars, and centuries of neglect, though much of it is now in ruin. Roman aqueducts still stretch across hills and valleys. Some ancient towers and temples have been rebuilt repeatedly over centuries, each generation adding new layers to the old. But tall buildings that housed people that reached beyond 3 or 4 levels rarely lasted. The higher the structure, the more energy was needed to keep it standing. The more levels it had, the more vulnerable it became. In time, practicality won. Low buildings were easier to maintain, safer to use, and less likely to fail. The dream of height never fully disappeared, but it would be many centuries before new tools, materials, and understanding made it truly possible. In the next part, we will explore how knowledge and building traditions were passed down across cultures and generations, and how that knowledge was preserved or lost in times of decline and change. In a world without printed blueprints, digital files, or standardized education, the knowledge of how to construct even the most basic building had to be preserved in other ways. It passed not through books, but from mouth to ear, from hand to hand, in traditions maintained across centuries. The skills that enabled a temple to rise, a palace to stand, or an aqueduct to stretch across a valley were quietly nurtured within communities of builders, masons, carpenters, engineers, and artisans who often learned by watching and doing, rather than reading or writing. In ancient Egypt, much of the building knowledge was concentrated among a small class of skilled laborers and scribes. These people lived near construction sites for years, sometimes decades, as they worked on pyramids or temples. Instructions for measurements and materials were sometimes inscribed on stone tablets or painted onto walls in tombs and workshops. Yet the bulk of practical skill came through apprenticeship. A young boy would learn from an elder how to shape stone, align blocks, or mix mortar. Tools were reused, methods repeated, and improvements passed down generation by generation, often without much change. In Mesopotamia, knowledge was preserved in the form of clay tablets. Some of these tablets contain what we now call architectural text, lists of materials, descriptions of foundations, and rudimentary measurements. Yet much of what was known was not formalized. Workers learned on the job, repeating what had been done before. Temples were rebuilt again and again on the same site, each one preserving the orientation and form of the last. Ritual and memory were as much a part of architecture as mathematics. In ancient Greece, ideas about proportion, symmetry, and ideal forms became more formalized, especially as philosophy merged with art and science. The architect was not just a builder, but a thinker. The use of columns, Doric, Ionic, and Corinthian followed rules of harmony and balance. These principles were passed on through teaching, often within families or small guilds. Stonecutters and sculptors guarded their methods, taking pride in their secret knowledge. But even here, detailed records were rare, and much of the work relied on practical knowledge built through experience. The Romans went a step further. Their engineers architecti had broader responsibilities. They planned roads, bridges, aqueducts, baths, and public buildings. Vitruvius, a Roman engineer and architect from the 1st century BCE, wrote De Architectura, one of the few surviving texts from the ancient world dedicated to building. In it, he described the qualities of a good architect, the materials used in construction, and the importance of proportion and utility. His work influenced generations to come, but even in his time, it was likely only one of many such bodies of knowledge, most of which were never written down. In India, construction knowledge was preserved in Shilpa Shastra's ancient texts, described the rules of art, craft, and architecture. These texts contained instructions on how to build temples, how to align structures with celestial movements, and how to shape icons and doorways. But even here, the most important knowledge was passed down in guilds where craftsmen worked and lived together. These guilds, known as shrinis, ensured continuity across centuries, keeping alive traditions that shaped stone temples, carved pillars, and ornate spires. In China, the building tradition emphasized timber construction. Knowledge was passed through master-apprentice systems with family workshops and imperial building departments maintaining continuity. Wooden brackets, beams, and joinery required extraordinary skill and precision. Ancient Chinese manuals, such as the Yingzhou Fashi compiled in the Song dynasty, documented architectural methods, though even this appeared much later than the practices it described. Before it, much of the tradition lived in the minds and hands of builders. Across Mesoamerica, where tall pyramids and ceremonial platforms rose, knowledge was also tied to ritual and myth. Builders followed cosmic patterns, aligning structures with solstices or sacred paths. While no complete architectural texts survive from the Maya, Aztec, or other civilizations, their cities show remarkable consistency in style and layout. It suggests that knowledge was passed within closed groups, perhaps. Priestly architects or noble-trained builders who kept their methods guarded and sacred throughout the ancient world. Building knowledge was vulnerable. When cities fell, when wars scattered populations, or when plagues and famines struck, those who held this knowledge might die, flee, or be absorbed into other cultures. Sometimes the knowledge was preserved through oral memory, other times through scraps of drawing or symbols etched into stone, just enough to guide the next hand. But knowledge could also be lost entirely. The collapse of the Roman Empire led to the loss of many engineering techniques in Western Europe. Arched bridges, large-scale aqueducts, and concrete construction disappeared for centuries. Similarly, the fall of cities like Teotihuacan or Angkor left behind ruins whose methods of creation were no longer understood by the generations that followed. Some techniques, once forgotten, would not be rediscovered until the modern age. Still, the idea of tall buildings remained. It lived in legends, in ruined towers, and in the memories of those who had once looked up at monuments that seemed to touch the heavens. These memories passed into stories, and the stories became symbols of greatness and mystery. In the next part, we will examine how myths and stories about tall buildings shaped future generations, and how the ruins of the past inspired dreams of height long before technology could make them real. Even as stone crumbled and beams gave way, the memory of tall buildings lingered. In a world where few structures rose higher than the treetops, the remnants of ancient towers, pyramids, and temples left a profound impression on those who came after. Travelers, poets, and priests stood before these ruins and wondered not only how they had been built, but why and what they might mean. Slowly, these tall buildings of the ancient world passed from reality into myth, becoming objects of fascination, fear, and longing. One of the most enduring myths came from Babylon, where the story of a mighty tower built to reach the heavens entered the traditions of later civilizations. Known today as the Tower of Babel, this structure was said to have been a unifying project for all humanity, until divine forces struck it down and scattered the builders by confusing their language. Whether rooted in real towers like the ziggurat of Etemenenki or entirely symbolic, the story carried a message that reaching too high might invite ruin. It reflected a truth that builders across time knew all too well: ambition without foundation could lead to collapse. In Egypt, the pyramids became a source of wonder for Greek and Roman visitors who no longer understood how such massive structures had been built. To them, the pyramids were not just tombs but expressions of some lost superior knowledge. Herodotus, writing in the 5th century BCE, guessed at the methods used, but much of his account was speculation. Over time, stories grew that the pyramids held secret treasures, that their design encoded cosmic truths, or that they had been built by giants or sorcerers. These tales filled the gaps left by the disappearance of the builders' techniques. In Greece, legends told of labyrinths, temples raised by the gods, and palaces so vast they echoed with the voices of kings long dead. The ruins of Mycenae, with its massive cyclopean walls, were believed to have been built by giants, since ordinary men could not have moved such stones. Even the Acropolis, whose ruins stood prominently above Athens, came to symbolize not just a city's power but a kind of lost glory, a connection to something greater than mere politics or warfare. Rome, too, became a land of legends after its fall. Medieval pilgrims and early Christian scholars wandered the ruins, unsure of their original purposes. They saw broken columns, fallen vaults, and half-standing aqueducts, and imagined a civilization blessed with wisdom and cursed by pride. The Colosseum, once a symbol of imperial spectacle, was thought to have been a temple or a fortress, or even a magical place built by ancient magicians. The very height of its walls invited stories, because so few people alive had ever seen something so vast. In India, the soaring temples of the south and the intricately carved stupas of the north inspired similar reverence. As centuries passed, legends merged with architecture. Builders were said to be guided by divine beings, or to have laid foundations on sacred energy lines. The taller the gopuram or spire, the more sacred its story became. When people no longer remembered who had built them, they assumed the gods had taken a direct hand. Throughout Asia, the same pattern appeared. In China, the great pagodas and ancient city walls were preserved or rebuilt, but sometimes their origins faded from memory. In Japan, where wooden buildings required constant care, older structures were frequently rebuilt from scratch, but always in the same form, guided by tradition and reverence for the past. When visitors stood before tall gates or towering palace halls, they were told not only about carpenters and emperors, but about spirits, ancestors, and dragons. Even in the Americas, where civilizations like the Maya, Aztec, and Inca had left behind stone cities and pyramids, later generations saw these structures as works of ancient heroes or gods. Spanish explorers and missionaries recorded local stories describing how giants or deities had created these cities in a distant time before memory. Some believed the buildings held messages from the stars. Others saw them as warnings from a lost age. Few imagined that ordinary people, using simple tools and deep knowledge, had shaped the stones one by one. These myths were not just fanciful. They served a purpose. In a world where most buildings were small and made of wood or mud, tall stone structures, especially those abandoned or in ruins, seemed to come from another realm. They defied ordinary experience. They seemed impossible. And so people made stories to explain them. Myths gave meaning to the mysterious and connected the living to the past. As the medieval world grew upon the ruins of the ancient one, many of these tall buildings remained visible but unused. They became part of the landscape, haunted, admired, feared. Pilgrims took stones from them as relics. Kings used them as fortresses. Monks wrote about them in illuminated texts. Artists painted them into backgrounds. Yet still the mystery of how they had been built remained. The higher the structure, the greater the mystery. And as long as these stories persisted, the dream of building high never fully vanished. It rested like dust on stone, waiting for the right conditions to awaken again. In the next part, we will look at the long centuries of the medieval period and how modest, low buildings slowly began to rise again, as cathedrals and castles setting the stage for humanity's next great leap upward. As the ancient world faded and the medieval era took its place, building traditions changed with the times. The great stone temples, palaces, and public monuments of past civilizations slowly gave way to modest, practical forms. After centuries of uncertainty, collapse, and recovery, people in the early Middle Ages no longer aimed for the sky. Their homes were made of wood, their churches of stone if they were lucky, and most structures rose no higher than 1 or 2 stories. But even in this quieter age, the desire to build upward remained, not through grand towers or pyramids, but through steeples, battlements, and spires. Much of Europe had lost the engineering traditions of Rome. The aqueducts no longer flowed. The secrets of Roman concrete faded. Roads crumbled and arches fell. In their place, a new style of building emerged, one that relied on tradition, local materials, and the slow rediscovery of old knowledge. The early medieval builders focused on what was possible. Strong foundations, thick walls, and small, enclosed spaces. But the tallest structures in a village were almost always the church, or the defensive tower places where height had meaning. Church towers, even small ones, became symbols of divine reach. They did not house people but bells, which called villagers to prayer and marked the passing of time. These towers were not particularly tall, perhaps 2 or 3 stories, but in a world of thatched roofs and single-room cottages, they dominated the skyline. Over time, these towers grew taller. Builders experimented with buttresses to support more height, and masons learned to cut more uniform stones. Techniques once known to the Romans began to creep back into use. One careful stone at a time. In regions like northern France and England, the Romanesque style gave way to the Gothic, a movement that would change the shape of medieval cities forever. Gothic builders reached higher than their predecessors, not with brute strength, but with new ideas. They used pointed arches, which distributed weight more efficiently. They added flying buttresses, which braced walls from the outside. They carved ribbed vaults that allowed ceilings to stretch wide and high. These innovations did not appear all at once. They were the result of centuries of slow experimentation, of failures followed by success, of stone cracking and mortar crumbling until the right formula was found. And yet, even with these tools, building tool remained difficult. The cathedrals of medieval Europe, Chartres, Notre Dame, Cologne, took generations to complete. Some required more than 100 years. Builders began work knowing they would never see the final stone placed. Designs changed mid-construction. Towers collapsed, spires leaned. Whole sections had to be rebuilt. Each cathedral was a gamble, a leap of faith, not only in theology, but in architecture, physics, and human persistence. These buildings were tall by medieval standards, yet still modest compared to modern towers. Even the highest spires rarely reached more than 150 meters. To achieve this height, labor was organized on a vast scale. Quarrymen cut stone blocks. Carpenters built scaffolding. Masons shaped and set each piece. Winches lifted loads by hand. Workers lived near the site for years. Churches raised funds through indulgences and donations. Towns competed for the tallest spire, not for comfort or convenience, but for symbolic glory. At the same time, castles and keeps rose across the countryside. These too aimed upward, less for beauty than for defense. A higher tower meant a longer view. A thicker wall meant a safer refuge. Castles were not built to inspire awe and heaven, but to withstand siege. Their height came in short bursts. Parapets, lookout towers, and defensive walls, often added piece by piece over decades. But even in this era, limits remained. Materials were still heavy. Tools were still primitive. Most people still lived and worked in low, dark spaces, lit by fire and shaped by the seasons. A tall building was a rare sight, and even rarer was one that lasted long without repair. Storms damaged roofs. Lightning struck steeples. Wars brought fire. Every gain in height came with an increase in risk. Still, the long centuries of the medieval period laid important groundwork. Builders rediscovered the importance of geometry, the use of templates and diagrams, and the value of recorded knowledge. Stonework became more precise. Tools became more reliable. Trades were passed through guilds, which preserved techniques across generations. Written documents, rudimentary, to be sure, began to supplement oral teaching. Height remained hard, and tall buildings remained rare. But the belief that humans could reach higher, that they could build into the sky with enough care, skill, and time, had returned. In the next part, We will explore the transition from medieval building to Renaissance, ambition, and how the revival of ancient texts and new discoveries began to make the impossible seem possible once more. As the Middle Ages began to wane and the Renaissance gradually took shape, the nature of knowledge itself began to change. For centuries, architecture had been preserved by experience through guilds, apprenticeships, oral instruction, and hands-on repetition. Now, however, the written word returned with greater force. Ancient manuscripts, long forgotten in dusty corners of monasteries or preserved in Arabic translation, were unearthed, copied, studied, and discussed. These texts reintroduced the West to the mathematical, scientific, and architectural theories of the ancient world, some of which had been inaccessible for over 1,000 years. Among the most influential rediscoveries was Vitruvius, the Roman architect whose treatise De Architectura described in careful detail how buildings could be designed according to proportion, function, and symmetry. His writing emphasized the connection between architecture and nature, between the human body and the buildings we create. Artists like Leonardo da Vinci famously studied these ideas, blending art and science in pursuit of perfection in form. But as important as Vitruvius was to the Renaissance imagination, his influence was also symbolic, a reminder that the ancients had built tall, strong, and beautiful structures, and that such achievements were not only possible, but perhaps repeatable. Still, reading about ancient engineering was not the same as understanding how it had actually been done. The Renaissance builders worked not from precise blueprints or computer models, but from geometry drawn with compass and straightedge, chalked onto stone or wood. Even in the most advanced cities of Italy, trial and error remained an essential tool. One miscalculation could bring down months or years of labor. Each inch of added height brought new risks, and every grand project had to contend with gravity, material strength, and human limitation. A towering example of this Renaissance ambition and its difficulties was the dome of Florence Cathedral, known as the Duomo. Designed in the 15th century by Filippo Brunelleschi, it would become the largest dome in the world at the time of its completion. But its construction was filled with uncertainty. Brunelleschi had no ancient blueprint to follow, and no one in Florence truly knew how to build a dome of such size without internal supports. Yet he succeeded, relying on careful mathematics, creative use of scaffolding, and custom-built machines to hoist materials. The Duomo rose not just as a structure of stone, but as a statement of possibility. It showed that with determination, knowledge, and daring, people could once again reach toward the heavens, not only in prayer, but in physical form. However, it is important to remember that even this astonishing feat topped out at a height that, by modern standards, would barely be considered a mid-rise structure. For its time, it was extraordinary, but it was still bound by the constraints of weight, labor, and stone. Elsewhere in Europe, cathedrals and bell towers continued to stretch upward. Architects experimented with balance, light, and verticality. The Gothic style still lingered, but Renaissance thinkers sought cleaner lines and more classical proportions. They studied Roman ruins with intensity, measuring columns, sketching arches, and seeking harmony in everything from floor plans to facades. Yet despite this passion for beauty, truly tall buildings remained elusive, because the core obstacles had not changed. Stone and brick remained heavy. Timber, though lighter, was vulnerable to fire and rot. Iron was used for reinforcement in small ways, but it was not yet produced or worked in sufficient quantities to support entire frames. Concrete, as the Romans had once used it, had been lost and would not be truly rediscovered until centuries later. The labor required to raise a structure even 50 meters high remained immense. Workers climbed scaffolding with buckets of mortar, Cranes were powered by men walking in wheels. Lifting and placing each piece demanded coordination, strength, and endless patience. And then there was the matter of urban space. Cities in the Renaissance were still organized horizontally. Streets were narrow, buildings were close together, and ventilation and light were constant concerns. A building that rose too high might block sun from the street or collapse onto its neighbors. Fire posed a serious threat in crowded districts. As a result, most residential and commercial structures remained low and dense, rarely exceeding 3 or 4 floors. Still, the Renaissance marked a subtle shift. It rekindled the dream of vertical grandeur. It revived the idea that buildings could not only protect or enclose, but could express ideas, aspirations, and ideals. Builders began to imagine not just what could be done with more time or money, but what might one day be possible with new materials, new machines, and new ways of thinking. In the East, similar developments occurred. In Ottoman Istanbul, builders raised majestic domes like those of the Süleymani Mosque, echoing both Byzantine and Islamic traditions. In Mughal India, tall gateways and slender minarets rose over symmetrical gardens and broad courtyards, blending aesthetics with structural mastery. Yet even in these traditions, the goal was elegance and harmony, not height for its own sake. By the end of the Renaissance, humanity had relearned much, but the true age of tall buildings had not yet arrived. It would require a new kind of revolution, one of industry, steel, and science. It would not come quietly or slowly. It would come in smoke and soot, with the clang of iron and the hum of machines. But before that, the world had to change in many other ways. In the next part, we will explore the industrial age, when materials, machines, and modern mathematics finally began to make height not only desirable but practical. As the Renaissance faded into the modern age, the world entered a time of profound transformation. The Industrial Revolution, beginning in the late 18th century and growing stronger into the 19th, did more than change how goods were made. It changed the very nature of building. What once took decades could now be achieved in years. What once depended on muscle and wind began to rely on coal, steam, and metal. And most importantly, the very materials of construction began to evolve. Thousands of years, humans had built with earth, stone, wood, and brick. These materials were heavy, inflexible, and often limited by their own weight. As buildings grew taller, the mass of the lower walls had to increase to carry the upper levels, making structures wide and thick at the base and limiting how high they could go. But now, new materials emerged, especially iron, and later, steel, which changed everything. Iron had been used before, of course, but in small quantities. Tools, nails, reinforcement for doors and gates. It was difficult to produce in large volumes and often brittle if not treated properly. But advances in smelting and refinement meant that by the 19th century, cast iron and wrought iron could be manufactured in larger, more consistent forms. Iron beams, columns, and trusses allowed for stronger frameworks that could carry more weight without the need for massive stone supports. One of the earliest public demonstrations of this new material's potential was the Crystal Palace, built in London in 1851 for the Great Exhibition. Though not especially tall, it was unlike anything that had come before. Made almost entirely of prefabricated iron and glass, it could be assembled quickly and disassembled just as easily. Visitors marveled at its transparency, its lightness, and its scale. It suggested that the old limits of weight and thickness could now be overcome. At the same time, steel began to surpass iron as the material of choice. Stronger and more flexible, steel allowed for vertical frames that could rise higher without buckling. For the first time, builders could create skeleton structures where the internal frame carried the load, and the outer walls could be thinner, and lighter. This was the birth of the modern skyscraper, though at the time no one called them that yet. But steel alone was not enough. To build tall, one also needed elevators. And this too became possible in the 19th century. In 1852, Elisha Otis introduced the first safety elevator, which used a simple but effective brake to prevent freefall. Suddenly, the upper floors of a building were no longer an inconvenience, they became desirable. Businesses could move upward. Cities could grow not just outward, but upward. And a new type of urban life began to form. Yet in many places, the psychological resistance to height remained. For centuries, buildings had been short and solid. Towers had often been symbols of power or faith, not places where ordinary people lived or worked. Even with the technology available, early tall buildings were cautious in form 5 or 6 stories at first, then 10, then 20. People worried about fire, about air quality, about access. The idea of being 50 meters in the air felt unnatural, even frightening. Safety codes, fireproofing, and public trust had to evolve alongside the architecture itself. In Paris, urban height was limited by regulation, preserving the horizontal character of the city. But in New York and Chicago, land was expensive and demand was high. Here, the new steel frame construction flourished. The home insurance building, completed in Chicago in 1885, is often cited as the world's first skyscraper. It stood only 10 stories high, but its internal steel structure made it revolutionary. Soon, architects and engineers began to dream bigger. Gothic cathedrals had once pointed upward as gestures toward heaven. Now, corporate headquarters, hotels, and office blocks rose as symbols of human ingenuity, ambition, and economy. Tall buildings were no longer impossible, but they still required tremendous coordination. Materials had to be shipped, workers trained, schedules managed. Cranes, pulleys, scaffolding, and hoists became standard on every construction site. Even with steel and elevators, the limits of the human body still imposed constraints. Workers carried loads on narrow beams. Bricklayers moved from level to level with little protection. Accidents were common. Weather was a constant concern, and cities had to adjust. Water pressure systems, electrical grids, and fire departments all had to adapt to vertical growth. Tall buildings were not just taller versions of shorter ones. They were entirely new environments, complex systems of structure, safety, and service. And still, even as towers rose and skylines began to change, many people remembered the past. The pyramids, the ziggurats, the temples and domes. They had stood as the tallest buildings in the world for centuries. Now, that era was ending. Stone was giving way to steel. Myth was becoming method. What had once seemed impossible was now the domain of engineers, draftsmen, and steel workers. In the next part, we will look more closely at the psychological and social impact of tall buildings, how they reshaped not only cities but also the way people saw themselves, their future, and the world around them. As the 20th century approached, tall buildings were no longer just a technical achievement. They began to shape human life in ways both visible and unseen. Once considered improbable or even dangerous, tall buildings became emblems of modern life. They dominated skylines, featured in photographs, became tourist destinations, and were woven into the identity of cities. But they also began to affect how people thought, lived, and moved. In the ancient world, most people had walked the earth, with the sky high above and the world laid flat before them. Buildings were low, the sun easy to see, and the stars not far from reach. Human scale matched the environment. Villages and towns were rarely more than a few stories tall. Even great emperors and kings resided in sprawling palaces rather than lofty towers. The vertical was associated more with mountains, temples, and heavens, not with everyday life. Now, that perception began to shift. In places like Chicago and New York, people found themselves looking upward every day. Office workers began their mornings in towering lobbies, rose through elevator shafts, and gazed out of windows hundreds of feet above the ground. For many, it was exhilarating. For others, it was disorienting. The experience of height, once the privilege of mountaintop ascetics or cathedral bell ringers, became ordinary. The skyline transformed from a natural line of trees and steeples to an artificial landscape of concrete and glass. And yet, humans remained human. Though the materials and methods had changed, the need for stability, safety, and comfort stayed the same. Architects now had to consider not only how to build tall, but how to make height livable. Air circulation had to reach every floor. Heat had to rise or be pumped across dozens of stories. Plumbing had to be reliable. Exits had to be planned in case of fire or power failure. The taller the building, the more complex the needs. Psychologically, the tall building presented a mixed message. To some, it was a marvel, a sign of progress, innovation, and ambition. To others, it symbolized detachment, hierarchy, or even alienation. People worked in cubicles high above the ground, but rarely knew their neighbors. Shadows cast by skyscrapers made city streets darker and colder. A single tall building might house hundreds or even thousands of people, and yet each might pass through their day in solitude. From above, the city changed. People once navigated by streets and corners. Now, they oriented themselves by towers, like ships to lighthouses. The skyline itself became a map visible from a distance, familiar to residents, instantly recognizable to outsiders. Every new building altered the silhouette, sometimes sparking celebration, sometimes controversy. Questions of taste, function, and skyline harmony arose in cities around the world. Still, the desire to go higher did not stop. New materials appeared. Concrete was strengthened. Reinforced steel, glass curtain walls, and modern cranes pushed the limits upward. Architects developed designs that accounted for wind sway, earthquakes, and weight distribution. Tall buildings no longer had to be square or simple. They could twist, taper, and spiral. In time, the towers of the 20th century would become taller, slimmer, and more expressive than anything previously imagined. And while skyscrapers rose in North America, they also appeared in Asia, the Middle East, and beyond. In cities like Shanghai, Dubai, Kuala Lumpur, and Seoul, tall buildings became symbols of growth and national identity. Yet they often grew from the same challenges faced by ancient builders: weight, material, space, and labor. The tools had changed. The scale had changed. But the principles had not. Meanwhile, many cities confronted the question of balance. How high was too high? Could buildings be beautiful and functional at once? Should the past be preserved or replaced? Should everyone live in tall buildings, or should only the wealthy rise above the streets? These debates echoed across the globe, from planning commissions to public forums. And through all of this, the human connection to height remained quietly profound. To build upward is to defy gravity, to seek perspective, to symbolically reach for something more. In ancient times, it had meant closeness to the gods. In modern times, it meant proximity to success, to power, to visibility. But still, whether in marble temples or steel towers, the human being inside remained the same. Aware of the height, conscious of the fall, and always striving for safety and meaning. The impossible struggle of the ancient world to build higher than the limits of nature allowed had, in a way, been overcome. But in overcoming it, new complexities had arisen. In the next part, We will explore the challenges of building truly tall in the modern era, and how even the greatest towers must still contend with old truths. Materials fail, nature pushes back, and nothing stands forever. By the time the modern era had fully arrived, the question was no longer whether tall buildings could be built. It was how tall, how safely, and to what end. The ancient limitations of material strength, lifting capability, and structural understanding had mostly been overcome. But a new set of challenges now emerge, many of them deeply tied to the laws of nature that had always defined what was possible. To build truly tall hundreds of meters into the air, higher than the tallest towers of old engineers had to contend with a fundamental force that had not changed: wind. As a building grows in height, it becomes more exposed. It no longer sits snugly within the shelter of a city, but begins to interact directly with the air around it. Wind exerts pressure. It swirls and pushes, sometimes gently, sometimes violently. And when it hits a tall, narrow structure, it creates oscillations, side-to-side movements that, while often imperceptible to the naked eye, can affect comfort, stability, and long-term durability. To combat this, modern skyscrapers use a variety of tools. Mass dampers, huge counterweights placed high in the building sway, in opposition to wind-induced movement, absorbing and reducing vibrations. Structural engineers shape towers to be more aerodynamic, allowing wind to pass more smoothly around them. Some buildings taper or twist to reduce drag. Others include open sections to let wind flow through, reducing resistance. But wind is not the only threat. In seismic zones, earthquakes pose another grave challenge. Unlike wind, which pushes steadily, earthquakes shake unpredictably. They can cause violent movement in multiple directions. And while ancient builders often learned the hard way what ground was safe to build upon, modern geotechnical engineering is far more advanced but still not perfect. Foundations for tall buildings in earthquake-prone areas must be deep, flexible, and highly reinforced. Still, even the best preparations cannot eliminate all risk. Then there is fire, one of humanity's oldest and most persistent enemies. In the ancient world, fire was the great destroyer of cities. Rome burned, Constantinople burned, London burned. And though modern materials are fire-resistant and sprinkler systems are widespread, a tall building remains vulnerable. Evacuation becomes more difficult the higher a building rises. Stairs must be wide and numerous. Elevators, under normal conditions, cannot be used during a fire. In the tallest towers, safety design becomes a form of art, one that must anticipate not only failure but panic, confusion, and time. Energy is another concern. Tall buildings consume a vast amount of power, not only for lighting, heating, and cooling, but also for vertical transportation. Elevators, escalators, pumps, and systems that maintain air quality must run constantly. Older buildings were passive in many ways. Thick stone walls retained heat, narrow windows minimized sun. But glass-covered towers require careful climate control, especially in extreme weather. Engineers must now design facades that can reflect sunlight, retain warmth, and allow for fresh air, often balancing aesthetics with environmental demands. Yet, despite all this, the drive to build taller continued throughout the 20th century and into the 21st. For many cities, a tall building is not just a place for work or living, it is a statement. The Empire State Building, the World Trade Center, the Petronas Towers, Taipei 101, the Burj Khalifa, all rose not simply from economic need, but from the desire to inspire, to represent national or civic pride, to stand apart in a crowded world. For every tower that succeeded, There were dozens that failed or were never completed. The cost of construction could balloon unexpectedly. Wind calculations might prove incorrect. Soil could shift. Materials might arrive late. Weather could delay progress. And even after a building opened, new challenges often emerge. Water leaks, sway complaints, elevator malfunctions. A tall building, unlike its ancient predecessors, is not simply built and done. It is a living system that must be maintained, constantly, often invisibly. And yet, the spirit that drove ancient builders, the ones who stacked stone in the deserts of Egypt, or carved temples from the cliffs of India, remains much the same. To build upward is still to test the boundary between earth and sky, between what is grounded and what is imagined. Modern engineers may use computers and steel, but they face the same questions. What will hold? What will endure? What will inspire? Tall buildings remain impressive, but they are not easy. They never have been. Even now, each one is a kind of gamble or wager that design, material, and human intention can stand against time, weather, and gravity. Every great tower is not only an expression of progress, but a reminder of how difficult that progress is to achieve. In the next part, we will reflect on the return to human scale, how in many places architects are now rethinking height, revisiting ancient methods, and asking whether building ever taller is truly the best path forward. As the modern era matured and cities grew ever more crowded and complicated, a quiet movement began to take shape, one that looked not upward but backward. It did not deny the marvels of tall construction, nor did it call for a full return to stone and timber. Rather, it asked a question that echoed through history. How much is enough? In this gentle reconsideration of height and ambition, architects, planners, and citizens alike began to explore the value of human-scale buildings, grounded spaces, and design rooted in older, sometimes forgotten principles. Throughout the 20th century, tall buildings had symbolized advancement. They demonstrated the power of industry, capital, and engineering skill. But as cities became more vertical, some began to notice the unintended consequences. Streets darkened under the shadows of towers. Wind tunneled through concrete canyons. Communities thinned out as neighborhoods were raised for high-rises. People lived and worked in boxes piled atop one another, efficient, yes, but often impersonal and unmoored from the earth. In many parts of the world, architectural nostalgia began to emerge. Urban planners revisited ancient city layouts, compact, walkable, with mixed-use buildings that stood only 3 or 4 stories tall. These towns had thrived for centuries without steel frames or elevators. Their streets were intimate, their buildings close together, their courtyards full of life. In these designs, it was easy to see one another, to hear footsteps, to open a window and speak to a neighbor across the way. Architects drew inspiration from medieval hill towns in Italy, Islamic Medinas in North Africa, and Japanese wooden districts, where structure and space existed in harmony with climate, culture, and daily habit. These environments had endured not because of height, but because of thoughtfulness. Materials were local. Buildings were adaptable. The scale was always related to the human body, its height, its pace, its reach. Modern interpretations of this philosophy emerged under names like New Urbanism, Biophilic Design, and Vernacular Architecture. In each, there was a shared belief that buildings should serve the people who use them, not merely impress those who look at them. In this sense, tallness was not a virtue by itself. A building could be tall and soulless, or small and meaningful. Size did not determine value, experience did. At the same time, advances in construction made it easier to revisit ancient techniques. Compressed earth, timber and natural allowed for sustainable low-rise buildings that were comfortable and durable. Passive solar design, where a building uses its shape and orientation to regulate temperature, was not new. It had been practiced for thousands of years. Ancient peoples had built thick walls to keep cool in the desert, placed windows to capture winter sun, and used shaded courtyards for ventilation. Now, these ideas were being revived, this time with the help of modern tools. And yet, even in the midst of this return to simplicity, tall buildings still stood. Some remained symbols of national pride or economic growth. Others served practical needs, especially in cities where land was scarce. But increasingly, architects began to blend old and new, using modern materials to construct buildings that felt timeless in form. A tall building, if designed well, could include green spaces, community areas, and elements of human scale that made it more livable. In this quiet architectural dialogue, the lesson from the ancient world was clear. It's not just what you can build, it's what you should build. The ancients had built low because they had to. Modern people built high because they could. But in both cases, success came not from height alone, but from harmony between form and function, between people and place, between ambition and humility. Even now, as skyscrapers rise into the clouds, many cities are choosing to limit height, to preserve sunlight, to maintain sightlines, to encourage community. Planners talk about livable density, where enough people share space to support businesses and culture, but not so many that the city loses its soul. In this way, the story of tall buildings is not only one of overcoming difficulty, but also of rediscovering balance. In the next part, we will return once more to the ancient builders, their tools, their choices, and the quiet brilliance of their restraint, as we reflect on how their challenges still whisper into the modern world, reminding us that higher is not always better. As we drift back to the distant past, it becomes easier to see not only what the ancients lacked, but what they understood. In a world without steel, concrete pumps, or computer modeling, the builders of old approached their craft with a mixture of caution, experience, and reverence. They did not have the means to build endlessly upward, but neither did they need to. For them, buildings were not isolated monuments, but integrated parts of nature and society, rising only so far as the earth, the gods, and the community would allow. Stone was heavy. Wood could rot. Bricks took time. Lifting was slow. Foundations had to be dug by hand. There were no powered cranes, no internal lighting, no safety harnesses. Every piece placed at height had to be hoisted with human strength, balanced with care, and secured with primitive tools. A single mistake could delay a project by weeks or end a life. And yet, the ancients built wonders that still draw awe. The pyramids of Egypt, the great temples of Greece, the ziggurats of Mesopotamia, the cliff dwellings of the American Southwest. These were not tall in the modern sense, but they aspired not just in physical height, but in meaning. They stretched toward the sky symbolically, often in layers or terraces, reflecting not only technical ability, but spiritual purpose. In each of these civilizations, building tall required more than resources. It required a shared belief, a reason to build that others could support. The laborers who shaped stone under the Egyptian sun did so under the rule of divine kingship. The masons of Greece worked to honor their gods. The Romans, more practical, built high to accommodate crowded cities, but even then rarely exceeded a few stories. Their insulae, early apartment buildings, were dense but unstable, often collapsing or burning. In time, Roman law even restricted building height to reduce these dangers. There was no fantasy of infinite height. There was instead a wisdom of limits and understanding that materials bent and broke, that walls could topple, that people needed light, air, and space to live well. Builders had to calculate these things without math as we know it. Their designs were often based on experience, passed down through generations, adjusted by trial and error. They built slowly, carefully, and mostly close to the earth. And still, with all their constraints, they created graceful, enduring forms. Columns were spaced not only for structure but for rhythm. Arches were added not just for strength but for beauty. Roofs sloped to shed rain. Floors were raised to stay dry. Cities spread outward rather than upward. Neighborhoods formed with narrow streets and shaded courtyards, not glass towers and parking garages. What's more, people understood where they were. They could navigate a town by landmarks, markets, temples, wells, trees, not by anonymous lobbies or elevator buttons. They lived in homes with walls they could touch and roofs they could mend. They watched the weather change. They smelled the earth after rain. They knew the sky not as a view from a penthouse, but as a daily presence just above the roofline, always visible. When height did appear, it meant something. A tower signaled danger or protection. A temple on a hill marked sacred ground. A ruler's palace might rise above the town, but only modestly so. It was not the norm, it was the exception. And in this, height retained power. It was rare, deliberate, meaningful. Modern life, with its tall buildings and ever higher ambitions, often forgets this. Height becomes ordinary. The sky disappears behind concrete. People rise hundreds of feet in seconds, unaware of the ground, disconnected from the world below. The ancient builders could not do this, but perhaps they also did not want to. Their buildings invited presence, participation, and memory. Their walls bore the marks of hand tools. Their stones fit together not because of machines, but because someone measured, chiseled, and lifted them with care. Their structures still stand not because they reached the clouds, but because they respected gravity, climate, and time. In the next part, we will look at how ancient builders influenced later periods, from medieval cathedrals to early Renaissance towers, and how each era reinterpreted the challenge of building upward with both old ideas and new desires. As centuries passed and the classical world gave way to the Middle Ages, the spirit of building changed again. The fall of Rome left behind broken aqueducts, ruined baths, and crumbling temple, symbols of a grandeur now lost. In the early medieval period, construction was modest, grounded, and deeply local. Buildings were made not with imported marble, but with whatever was close at hand: rough stone, timber, earth. And yet, even in this age of scarcity and isolation, the dream of reaching upward never fully vanished. This quiet desire found new expression in church towers and cathedral structures that sought not just to house people but to glorify the divine. In towns across Europe, stonemasons and builders slowly turned from squat churches to soaring spires, each one a physical gesture pointing to heaven. But these projects were not swift or simple. A cathedral could take decades or even centuries to complete, begun by one generation and finished by another. The tools remained primitive. The materials were heavy. The risks were great. Builders worked with scaffolding made of wood, tied together by ropes, lashed to the sides of growing walls. They climbed ladders, hoisted blocks with pulleys, and mixed lime mortar by hand. A single storm could delay work for months. A war or a failed harvest could end it altogether. And still, they built stone by stone, carving tracery in arches, installing stained glass, and pushing higher, ever higher. These structures were not true skyscrapers, but they were extraordinary for their time. The spire of Lincoln Cathedral, completed in the 14th century, briefly became the tallest structure in the world. Chartres, Cologne, and Rouen rose to rival mountains, but with every added meter came new dangers. Foundations had to be reinforced. Walls had to taper as they climbed. Flying buttresses, arch supports anchored in the ground, were introduced to absorb lateral forces and keep walls from bowing outward. These were technological answers to old limitations, discovered slowly, often painfully. Yet even with these advances, mistakes happened. Towers cracked. Vaults collapsed. Roofs failed. There was no perfect formula, only a constant negotiation with stone, weight, and time. And beneath the grandeur was always the labor, the quarrying, the chiseling, the lifting. For every celebrated architect, there were hundreds of workers unrecorded, unnamed, who gave their strength and lives to these monumental projects. In the Islamic world, a different approach to height emerged. Minarets, tall slender towers, beside mosques, rose across cities from North Africa to Persia and India. Unlike massive cathedrals, these structures emphasized lightness and vertical rhythm, often decorated with intricate tilework or calligraphy. Their purpose was both spiritual and practical, to project the call to prayer across rooftops. Though not as structurally demanding as European towers, they still represented a controlled ascent, blending beauty and geometry within the boundaries of material possibility. In China, tall pagodas served religious functions as well, rising in tiers, often wooden at first, later built from brick and stone. These towers were symbols of Buddhism and repositories for sacred relics. The early wooden versions were prone to fire, collapse, or decay, but their design stacked layers with broad eaves offered a balance between vertical ambition and horizontal grace. These medieval experiments in verticality all relied on accumulated knowledge, what had worked before, what had failed, and what could be slightly pushed forward. Geometry was still used intuitively. Trial and error remained a primary method, and height was never taken for granted. To build tall was to court danger and wonder alike. Importantly, these tall structures were rarely built in isolation. They were anchored to communities, surrounded by marketplaces, homes, and gathering places. A tower or spire was not simply an object in the sky, it was a part of the town's identity, visible from fields and roads, reminding residents of time, faith, and shared purpose. Even when ambition led to collapse, the desire remained. Builders returned to their plans, altered the shape, tried again. Failure was not always the end, it was part of the process. In this sense, tall buildings in the medieval world were not expressions of dominance, but of patience, persistence, and meaning. In the next part, we'll move into the Renaissance and early modern periods, where rediscovered classical knowledge, improved materials, and growing wealth allowed builders to once again imagine taller, more complex structures, and where new tensions emerged between beauty, function, and structural possibility. As the Renaissance unfolded in Europe, a slow but steady transformation swept across the built environment. This was not just an age of paintings and philosophy. It was also a time of rediscovery. Ancient Roman texts on architecture, particularly Vitruvius' De Architectura, were unearthed and studied by scholars and builders. For the first time in centuries, there was a conscious return to classical ideals: symmetry, proportion, and measured form combined with new techniques, growing wealth, and a renewed confidence in human potential. And with this shift came a fresh interest in building taller. But even in the Renaissance, builders could not defy the fundamental limits that had restrained the ancients. Materials were still largely the same: stone, timber, brick, and gravity remained relentless. What changed was not so much the possibility of unlimited height, but the willingness to experiment with vertical space within reason. Domes rose above churches, towers were added to palaces, and facades became more elaborate. The buildings may not have reached the clouds, but they felt taller through clever design and improved techniques. One of the most celebrated architectural feats of the Renaissance, the dome of Florence Cathedral, designed by Filippo Brunelleschi, offers a clear example of innovation within limitation. Constructed without traditional wooden scaffolding, the dome used a herringbone brick pattern and a series of rings and ribs to maintain its shape as it rose. It was an extraordinary achievement for its time, not only because it stood over 100 meters tall, but because it did so without collapsing during or after construction. The dome was not merely high, it was carefully calculated, drawing from ancient knowledge and adapted to new materials and methods. Elsewhere, similar trends could be seen. Bell towers were added to churches. City halls grew more imposing. In Venice, the Campanile di San Marco, a simple but towering brick structure, stood as both lighthouse and civic symbol. In Rome, the resurrection of classical forms inspired structures that honored the past while pointing to the future. But still, most buildings remained only a few stories tall. Even in thriving urban centers, height was constrained by structural limitations, fire risk, and the absence of fast transportation inside buildings. No elevators, no escalators, only stairs. As wealth concentrated in cities, there was a growing demand to use land more efficiently, especially in trade hubs like London, Amsterdam, and Paris. Merchants and artisans built homes with multiple floors, but the upper stories were narrow, often made of lighter wood to reduce weight. These buildings leaned inward over the streets, sometimes nearly touching across narrow lanes. Here, vertical expansion was practical, but also precarious. Fires spread rapidly and maintenance became difficult. Regulations were eventually introduced, in some cities to limit height and standardize materials, not out of ambition, but out of necessity. The Renaissance also marked the beginning of military architecture's transformation. As cannons became widespread, fortresses changed from tall towers to low, thick bastions, emphasizing strength over elevation. Tall walls, once symbols of power, became liabilities. It was a shift that once again reminded builders that height alone was not always wise or safe. It had to match purpose. In the East, similar evolutions took place. The Mughal Empire in India, for example, combined Persian, Islamic, and local traditions to build majestic structures like the Qutub Minar, a victory tower that soared nearly 73 meters. Built centuries earlier, it remained one of the tallest masonry towers in the world, a sign of just how rare and difficult such height was to achieve. In China, during the Ming and Qing dynasties, height was less emphasized than spatial harmony, with architectural complexes laid out horizontally around courtyards, respecting axial symmetry and feng shui principles. Here again, groundedness was more desirable than vertical show. Ultimately, during the Renaissance and early modern period, building tall was still an exception, not a rule. It remained expensive, dangerous, and difficult to maintain. What mattered more than reaching high was building intelligently, with grace, strength, and meaning. When height was pursued, it was for specific reasons: religious inspiration, civic pride, military advantage, or a patron's ego. And even then, it was tempered by centuries of caution and an intimate understanding of what stone, wood, and labor could truly withstand. In the next and final part, we'll explore the slow shift into the industrial age, when iron, steel, and the elevator would finally break the ancient height barrier, reshaping skylines forever, and reflect on what was gained and what may have been left behind. As the world inched toward the industrial age, everything began to change, not suddenly, but steadily, like steam gathering in an old kettle. The slow pace of traditional building, shaped for millennia by hand tools, gravity and patience, was gradually overtaken by the rise of new materials, machines, and ambitions. For the first time in human history, the long-held limitations on height, so deeply understood by the ancients, respected by the medieval builders, and tested by the Renaissance architects, began to crack. And as they did, a new chapter opened, one where buildings would no longer grow just outward, but upward. At last, the key change was not merely cultural, but material. For centuries, stone and brick had been the primary means of construction. Both were strong in compression but weak in tension, making tall structures inherently risky and extremely heavy. But in the 19th century, something new emerged: iron and later steel. These metals could bear far greater loads, span longer distances, and support more stories with less bulk. Unlike stone, they did not crumble under their own weight. They could bend, stretch, and when joined with concrete, create frames that allowed buildings to rise far above the ancient ceiling. The second revolution was the invention of the elevator. Even if buildings could be made taller, few people would willingly climb 10 or 15 flights of stairs multiple times a day. But with the development of the safety elevator by Elisha Otis in the 1850s, vertical transportation became fast, safe, and practical. It transformed the upper floors from undesirable garrets into prime real estate, giving builders and investors the incentive to push higher. By the late 19th century, the first true skyscrapers began to appear initially in cities like Chicago and New York, where land was valuable and demand was high. The Home Insurance Building, completed in 1885 in Chicago, stood at just 10 stories, but was revolutionary in its use of a structural steel frame. From there, the race quietly began. The ancient barrier had been breached, yet it's important to note that the transition was not instantaneous. Many old fears remained. Early steel-framed buildings still imitated classical stone architecture. Builders added unnecessary columns, pilasters, and heavy facades to make these new buildings look familiar. It would take time before people became comfortable with buildings that looked modern, that revealed their frames, that used glass, that felt light and open instead of solid and massive. By the early 20th century, the skyline had changed. Towers like the Woolworth Building, the Chrysler Building, and finally the Empire State Building rose over New York, each a marvel of engineering, each standing far higher than anything the Romans, Greeks, or Egyptians could have imagined. These were not just buildings, they were symbols of commerce, power, progress. Their height was no longer constrained by material or method. The limits were now economic, political, or psychological. And yet, in this new world of upward possibility, something of the ancient wisdom was slowly lost. No longer did communities gather around shared public spaces shaped by low buildings and visible skies. No longer did roofs echo the slope of the climate, or walls reflect the material of the region. Instead, glass, steel, and concrete spread across the world, standardized and global. One city's skyline began to resemble another's. Local building traditions, shaped by thousands of years of weather, culture, and belief, faded beneath the weight of vertical ambition. Tall buildings became ordinary. They no longer required spiritual purpose or generational labor. They could be drawn in a week, approved in a month, built in a year. Machines lifted beams into place. Workers followed blueprints. Floors appeared by the dozen. Elevators zipped past windows. And the sky, once so close, so visible, so sacred, became something glimpsed through tinted glass on the 50th floor. Still, the story of height remains a story of humanity. From the low huts of the first villages to the spires of cathedrals and the towers of global cities, we have always looked up, dreamed up, and when able, built up. What changed was not the desire, but the means, and what remained quietly in the background was gravity, the same silent force that challenged the builders of Babylon and still whispers its warning today. For the ancients, height was a miracle. For us, it is a measurement. But perhaps, in remembering the long struggle to rise even a few stories, we can find a new respect for the earth beneath us and the hands that once lifted stone by stone, year by year, with no machines, no motors, just purpose, patience, and an eye on the sky. Thank you for listening to this long, slow journey through the forgotten challenges of building tall in the ancient world. If you've stayed with us until now, perhaps your mind has wandered gently, or your eyes have grown heavy. Wherever you are, may you rest well, and may history continue to whisper softly, like distant echoes through quiet stone halls.